Chapter 8, Periodic Properties of the Elements. I skipped section 8.1. Don't remember why off the top of my head. You should read it, but I'm not going to test you on anything in there. So Dmitri Mendeleev lived mostly in the 1800s. He is often given credit as the father of the modern periodic table. He looked at the elements that had been discovered and their properties and tried to make some order out of them, because up until then they had all different countries called them different names, and they were just sort of a list of random things. So what he observed, and is called the periodic law, is that when you arrange the elements in order of increasing atomic mass, certain properties recur periodically. And this is a little bit like what happens on a piano keyboard. See if I can draw a piano keyboard. That's, I'm not even going to go there. I know what one looks like, but drawing it requires too much mental energy. On a piano keyboard, there's the note C. And if you go up an octave, there's another C. And they are related to each other. There's a pattern in the notes. And we see similar patterns in the elements. And so he arranged the elements in this way, and then he used the patterns that he observed to predict that elements would be discovered to fill in the gaps. Occasionally he came across a couple of elements that did not work out very well if he used atomic mass. And one example is tellurium and iodine. And if you look at the periodic table, we see that tellurium comes before iodine in the periodic table, but tellurium has a mass of 127.6, and iodine is 126.9. The mass of iodine is actually less than the mass of tellurium. But if you put them the other way, in order of increasing atomic mass, the properties don't line up. Because iodine has properties in common with bromine, chlorine, fluorine, etc. And tellurium doesn't. Tellurium has properties more similar to those of selenium. Two of the elements that he predicted would be discovered are gallium and germanium. And here we have the properties that he predicted for gallium and the actual properties of gallium. And as we see, he predicted formulas of oxides and chlorides, exactly correct. The density, very close. Melting point, this was just sort of an approximation, but still really good, because gallium is a metal that melts at 29.8 degrees Celsius. That means if it's sitting out on the counter, it's a solid, but if you hold it in your hand, it will melt. Kind of crazy. And germanium, and here's his predictions and the actual properties that were found for germanium when it was discovered. So Mendeleev's periodic law helps us to predict what is going to happen. He was able to predict elements that had not yet been discovered. But it doesn't understand why there is this pattern in the periodic table. And quantum mechanics is the theory that does explain why we see these periodic trends. And knowing why allows us to predict even stronger what will happen.